What if the greatest discovery in human history has already been made, and for 40 years you were never told? Imagine a truth so profound, so unsettling, that it was deemed too dangerous for public knowledge. A secret locked away, not in a fortified vault, but buried in plain sight, hidden within columns of forgotten numbers on a dusty magnetic tape. We place our faith in the steady march of science, believing discovery to be a public spectacle, a triumphant announcement shared with the world. We celebrate the new telescope, the distant galaxy, the first glimpse of a cosmic dawn. But this comforting narrative of open exploration, of shared human endeavor, presumes a fundamental honesty at its core. It presumes that when we gaze into the void and the void gazes back, the first people who see it will tell us what they saw. The story you are about to witness challenges that presumption. It suggests that our cosmic history, the very timeline of our awakening to the universe, is a carefully edited draft, and that the original manuscript containing a shocking revelation has only just been unearthed. This is not a story of what we might find one day in the future. It is the story of what was found yesterday, a lifetime ago, and promptly concealed from view. For millennia, our solar system was the entirety of creation, a celestial clockwork of familiar lights against a static backdrop of painted stars. You know their names, their faces, their orbits, as well as you know the continents on a globe. There is the searing furnace of Mercury, the suffocating blanket of Venus, the rust-red deserts of Mars, a world of tantalizing ghosts and shattered dreams. Beyond them lie the Titans, the gas giants, each a universe unto itself. Jupiter, the raging storm king, a gravitational anchor that protects and sometimes condemns us, its great red spot, a hurricane larger than our entire planet, churning for centuries. Saturn, the jewel of the night sky, its rings a breathtaking spectacle of ice and rock, a shimmering halo that has inspired awe since the first eye was aided by a lens. Then, further out into the deep cold drift, the ice giants Uranus and Neptune, ethereal blue wanderers in the gloom, their secrets only dimly perceived by the fleeting glances of our robotic emissaries. This is our family, our cosmic neighborhood. We have mapped its every corner, from the scorched surface of the inner worlds to the frozen plains of Pluto and the scattered debris of the Kuiper Belt. For all of history, we believed this was a closed system, a snow globe, sealed by the immense dark frontier of interstellar space. The outer boundary, the very fence of our celestial property, was thought to be the Oort cloud, a theoretical stupendous sphere of trillions of icy bodies, the frozen remnants of our system's birth. It is a ghost realm, a dark halo, surrounding us at a distance so vast that light itself takes more than a year to cross it. From this frozen reservoir, the great comets are sometimes nudged inward, falling toward the sun in majestic arcs that can span millennia. They were our only long-distance callers, messengers from the cold outer darkness of our own home, but they were always times ours, asterisk. They carried the chemical signature of our nebula, the primordial dust and gas from which you and I and everything we have ever known was born. They were family returning from a long journey. The space between the stars, the gulf separating our sun from its nearest neighbors like Proxima Centauri, was considered an impassable void. Nothing we believed could cross it. It was too vast, too empty, too cold. Any object not gravitationally shackled to a star was thought to be a cosmic impossibility, a wanderer doomed to an eternity of lonely darkness. For an object to be ejected from its own star system would require a cataclysm of unimaginable violence. For it to then navigate the gravitational labyrinth of the galaxy and happen to find its way to our tiny doorstep was a statistical fantasy, an event so improbable it was relegated to the realm of speculative fiction. We were, for all intents and purposes, an island universe utterly alone. Then, on the 19th of October 2017, that comforting illusion of solitude was shattered forever. A telescope in Hawaii, scanning the heavens for killer asteroids, flagged a faint, fast-moving point of light. Astronomers scrambled to track it. As they plotted its trajectory, a wave of disbelief followed by electrifying excitement swept through the global scientific community. The path was not an ellipse, nor a gentle parabola, the classic closed circuits of objects bound to our sun. This object's path was a dramatic hyperbolic slash across our solar system, a clear indication that it was not from here. It had come from the outside. It was moving too fast, unbound by the sun's gravity, and was already on its way back out into the galaxy, never to return. They named it Oumuamua, a Hawaiian word for a messenger from afar arriving first. It was our first confirmed interstellar visitor, and it was bizarre. It was small, no bigger than a city block, and shaped according to the faint glimmers of light reflecting from its surface like a shard or a cigar. It tumbled through space in a chaotic spin, and most unnervingly, it was accelerating slightly, pushing away from the sun with a force that could not be explained by the outgassing of ice like a normal comet. It was a dry, rocky alien enigma. Speculation ran wild. Was it a new kind of celestial body, the fragment of a shattered world from another star? Or, as some dared to whisper, was it something more? A piece of technology, a probe sent by an intelligence we cannot comprehend. Oumuamua was a cosmic riddle that appeared without warning and vanished back into the darkness, leaving us with more questions than answers. Just 2 years later, a second traveler arrived. This one, discovered by amateur astronomer Gennady Borisov, was more familiar. Named 2I, Borisov, it behaved like a comet sprouting a ghostly tail of gas and dust as it neared the sun. But its chemistry, the very elements cooking off its surface, was subtly alien. It contained levels of carbon monoxide unlike any comet from our own Oort cloud. It was a pristine sample from a completely different stellar nursery, a chemical message in a bottle from a distant unknown shore. The discovery of 2 such visitors in as many years forced a profound re-evaluation of the cosmos. The void, it turned out, was not so empty. The space between the stars was a highway teeming with wandering worlds, icy messengers, and rocky debris cast off from alien suns over billions of years. A new window on the universe had been thrown open. We were no longer an isolated island. We were a port of call on a galactic ocean, and the ships of other harbors were finally beginning to wash ashore. Astronomers began eagerly hunting for the next one, desperate to get a closer look, to analyze a fresh piece of another star system. They pointed their most powerful instruments toward the void, waiting for the third knock on our door, another chance to study a true alien. And then it came. Or so the official story goes. In the early 2020s, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a robotic survey designed to find celestial threats, identified a new object. Its trajectory was definitively interstellar. The world was introduced to 3I, Atlas, the third confirmed visitor. Immediately, it presented a fresh mystery, one that was deeper and stranger than its predecessors. It was enormous, potentially the largest interstellar object ever detected, a behemoth dwarfing both Oumuamua and Borisov. Its composition was baffling, a curious mix of rock and exotic ices that defied easy categorization. But its most perplexing feature was its orbit. When astronomers traced its path backward in time, they calculated that it had made its closest approach to the sun decades ago, long before our modern sky surveys were powerful enough to have seen it. It had swung through the inner solar system in near total obscurity, a ghost in the machine, and was now on its long, slow journey back out into the abyss. It was a missed opportunity, a spectacular guest who had come and gone while we weren't looking. Scientists around the world raced to study its fading light, piecing together the scant clues of its nature from a distance, lamenting that they had not been watching the skies more carefully in the past. It was a story of a near miss, of a discovery made just a little too late. But that entire story, every headline, every scientific paper, every lamentation of a missed opportunity was built upon a lie. Not a deliberate deception perhaps, but a lie of omission born from a secret that had been gathering dust for 40 years. 3I Atlas was not discovered in the 21st century. It was first seen its impossible journey, first recorded in 1983. The year is 1983. The Cold War is at its frostiest peak. The world is a chessboard of superpowers, of nuclear tension and whispered espionage. Technology is advancing at a breathtaking pace, but it is a world lit by cathode ray tubes, connected by dial-up modems, and powered by data stored on cumbersome reels of magnetic tape. In this era of secrets and suspicion, humanity launched a revolutionary eye into the sky. It was called IRAS, the Infrared Astronomical Satellite, a joint project between the United States, the Netherlands, and the United Kingdom. Its mission was unprecedented. For 10 months, orbiting high above the atmospheric veil that blinds us to so much of the cosmos, IRAS would systematically map the entire sky, not in visible light, but in the invisible spectrum of infrared. It was designed to see the universe of the cold, the dark, and the hidden. It could peer through dense clouds of interstellar dust to witness the birth of new stars hidden deep within their stellar nurseries. It could detect the faint residual heat of asteroids and comets that were too dark and distant to be seen by conventional telescopes on Earth. IRAS was a celestial cartographer tasked with creating the first complete map of the infrared heavens, charting the heat signatures of everything from our own cosmic backyard to the cores of distant galaxies. It was a marvel of engineering cooled by superfluid helium to near absolute zero to ensure its own heat would not blind its exquisitely sensitive detectors. For 300 days it scanned the sky in sweeping strips, a silent, methodical sentinel in the dark. It catalogued hundreds of thousands of previously unknown infrared sources, revolutionizing our understanding of the universe. It discovered new asteroid belts, found the dusty disks around other stars, where new planets might be forming, and gave us our first glimpse of the glowing supermassive black hole lurking at the heart of our own Milky Way galaxy. The mission was a resounding success, its data a treasure trove that astronomers would continue to mine for decades to come. But within that vast archive, that digital library of the cold cosmos, one detection stood out. It was a single anomalous point of heat registered by the satellite's detectors as it swept across a seemingly empty patch of the southern sky. On the raw data feeds, it would have appeared as just a flicker, a momentary spike in energy. But the onboard computer's program to identify moving objects flagged it. The source was not stationary like a star or a galaxy. It was moving, and it was moving fast. Standard procedure kicked in. The satellite's observations were cross-referenced with catalogues of known objects. It wasn't a planet. It wasn't a known asteroid. It wasn't a registered comet. It was new. Scientists at the Jet Propulsion Laboratory, tasked with analyzing the IRAS data, would have tried to calculate its orbit to determine where it came from and where it was going. And this is where the story takes a chilling turn, where the official narrative of scientific discovery diverges into a shadow history of classified knowledge. When they plotted the object's trajectory, the numbers would have seemed impossible, a gross error in the data. The object's velocity and angle of approach did not conform to any possible orbit within our solar system. It was not falling in from the Oort cloud. It was not a wayward asteroid from the belt between Mars and Jupiter. The mathematics was unforgiving, the conclusion inescapable. The object came from interstellar space. In the tense, paranoid atmosphere of 1983, at the height of the Cold War, in an era when unidentified flying object was a term loaded with military and political implications. What did they do with this information? What does a small, overworked team of scientists do when they find the first definitive proof that we are not alone, that an object from another star was at that very moment passing through our home? We now know what they did. Nothing. There was no press conference. no triumphant announcement, no emergency cable to the world's observatories. The object was given a provisional, forgettable designation. Its data, a handful of infrared measurements on a magnetic tape, was filed away. It was buried in an avalanche of information, one strange data point among millions, a cosmic whisper that was immediately silenced. Was it a deliberate act of suppression? Was this single world-altering discovery deemed too sensitive, too disruptive, for a world already teetering on the brink of conflict? Did a quiet order come down from some unseen authority to classify the finding, to bury the signal in the noise until the world was ready for such a truth? Or was it a more mundane and perhaps more terrifying failure of imagination? Did the scientists simply not believe their own data? Did they assume it was an instrument error, a glitch in the satellite, a ghost in the machine, because the alternative, that a true alien had arrived, was simply too fantastic to contemplate? The truth is likely a complex tapestry woven from all these possibilities of caution, of disbelief, of bureaucratic inertia, and perhaps of outright fear. For 40 years, the discovery remained dormant, a secret kept not by armed guards, but by obscurity. Until now. The recent declassification of the complete raw IRAS archive, coupled with the power of modern computing, has allowed us to go back to re-examine that cold case. With our new understanding of interstellar objects, prompted by the discoveries of Oumuamua and Borisov, astronomers knew what to look for. They combed through the old data, hunting for faint heat signatures on hyperbolic trajectories. And there it was, that anomalous flicker from 1983. When they plotted its path forward through time from its point of detection 4 decades ago to the present day, it led them directly to the fading light of the object our modern telescopes had just found, and named 3I, Atlas. They were one and the same. The great modern discovery was in fact a rediscovery. The visitor we thought we had just missed had actually been seen, recorded, and logged by humanity on its first pass. We didn't miss our chance. We had our chance, and for reasons we are only just beginning to investigate, we let it go. We threw it away. This revelation completely rewrites the history of one of the most exciting new fields in astronomy. It means Oumuamua was not the messenger from afar arriving first. The first messenger arrived in 1983. Its signal was received. And then, the message was locked in a drawer. This single fact explodes our timeline and forces us to confront a deeply unsettling set of questions. The most important of which is no longer are we being visited, but for how long has this been happening? And more importantly, what else don't we know? Now, with the original data finally in hand, we can begin to answer the most pressing question of all. What exactly did IRAS see in 1983? The satellite didn't just detect a point of light, it measured its heat, its size, its infrared color. This is data of a quality we could never hope to capture today, now that the object is so far away. It is a scientific time capsule, containing pristine information about a true alien object captured at close range. Did it see something in that data that was so strange, so unnatural, that it justified 40 years of silence? Why was the existence of 3I, Atlas, the first confirmed emissary from another star system, a secret kept from the world? And as we finally unlock the contents of this 4-decade-old data tomb, what will this messenger from the deep past finally tell us about our true place in the cosmos? The search for answers begins here, in the cold, hard numbers of a forgotten file, from a world on the brink, and a discovery that could change everything. What if the most profound astronomical discovery of our time was not made in a gleaming modern observatory, but was instead captured 40 years ago and then simply lost? Not lost to catastrophe or espionage, but buried alive within a mountain of antiquated data, a ghost in a primitive machine. Imagine a cosmic message in a bottle, meticulously recorded on reels of magnetic tape catalogued, and then filed away its true significance, utterly missed by the very pioneers who had reached out to grasp it. To unravel this enigma, we must journey back, not just through space, but through time. The year is 1983. The world is a landscape of stark division, a planet cleaved in two by ideological fervor and the chilling logic of mutually assured destruction. The Cold War is not a memory, but a raw daily reality, and the heavens above are the ultimate high ground, a theater for the ambitions of superpowers. On Earth, the air crackles with tension. In the silent vacuum of space, that tension manifests as a technological duel. Satellites crisscross the globe, some looking down with military precision, others looking out with scientific curiosity, both driven by the same engine of national prestige. Astronomy in this era is a pursuit of giants. On remote mountain peaks, colossal telescopes, architectural marvels of steel and glass, nightly open their cyclopean eyes to the visible universe. They gather the faint, ancient light of stars and galaxies, the same photons our ancestors saw, only magnified a millionfold. They produce breathtaking portraits of cosmic grandeur, the incandescent swirl of the Andromeda galaxy, the jewel-box glitter of globular clusters, the ethereal pastels of the Orion Nebula. This is the universe we think we know, the one rendered in the familiar rainbow of colors our eyes evolved to see. But it is a profound deception. For all their power, these terrestrial behemoths are fundamentally blinkered, peering at the cosmos through a keyhole. They are bound by the physics of visible light, a narrow, almost insignificant sliver of the full electromagnetic spectrum. They cannot penetrate the great curtains of interstellar dust that hang like cosmic smoke between the stars, obscuring the most violent and creative processes in the universe. Behind this veil, new suns are being born in furious bursts of energy. Galactic cores are churning with the gravitational fury of supermassive black holes, and the very building blocks of planets are slowly, patiently coalescing in the box, dark. To the great optical telescopes of the early 1980 seconds, these vital arenas are entirely invisible, forever locked away in shadow. To see into these forbidden realms, to witness creation at its source, you would need an entirely new kind of eye. An eye that doesn't see light, but sees heat. This was the audacious dream behind the Infrared Astronomical Satellite, or IRAS. It was not just another telescope, it was a revolutionary leap of perception. A collaboration between the United States, the Netherlands, and the United Kingdom, IRAS, was an act of scientific diplomacy in a fractured world, a testament to the unifying power of cosmic curiosity. Its mission was breathtakingly simple in its goal and terrifyingly complex in its execution: to create the very first complete map of the entire sky, not in visible light, but in the ghostly thermal glow of infrared. It was conceived to chart the unseen universe, to pull back the dusty veil, and reveal the hidden engines of the cosmos. To achieve this, IRAS had to become one of the coldest objects ever launched into space, a masterpiece of cryogenic engineering. The universe is saturated with heat. Even the empty void between stars has a faint background warmth. To detect the incredibly subtle thermal signatures from nascent stars or distant dusty galaxies, the telescope's own detector had to be colder than the signals it was trying to capture. Any heat from the instrument itself would be like trying to listen for a whisper in the middle of a rock concert. The noise would overwhelm the signal. The solution was as elegant as it was ephemeral. The entire telescope, its mirrors, and its state-of-the-art 62-pixel detector array was submerged in a cryostat, a sophisticated thermos bottle containing 73 kilograms of superfluid liquid helium. This chilled the heart of IRAS to a staggering 2 degrees above absolute zero, just a hair's breadth from the coldest temperature physically possible, the point where all atomic motion ceases. This cryogenic lifeblood gave IRAS its vision, but it also placed the mission on a relentless clock. The liquid helium was constantly slowly boiling away into the vacuum of space, a steady sacrifice to maintain the instrument's exquisite sensitivity. From the moment of its launch on January 25, 1983, from Vandenberg Air Force Base, a countdown had begun. IRAS had approximately 10 months. 10 months to survey the entire celestial sphere 4 times over, to paint a complete picture of the infrared heavens before its coolant vanished and its eye was permanently blinded by its own heat. It was a sprint, a frantic, high-stakes race against the unyielding laws of thermodynamics. For the scientists on the ground, every second of data was precious, a fleeting glimpse into a universe no human had ever seen before. The anticipation within the astronomical community was electric. For decades they had been working with theoretical models inferring the processes hidden behind the cosmic dust. IRAS promised to transform theory into observation, speculation into fact. The list of expected discoveries was itself a revolution in the making. Chief among them was the quest for protostars, the holy grail of star formation. Astronomers knew that stars were born from the gravitational collapse of immense clouds of gas and dust. As the cloud collapses, its core heats up, forming a dense, hot knot of matter, a protostar. But this stellar nursery is shrouded in the very dust from which it is born, completely opaque to optical telescopes. All that escapes is heat. IRAS, it was hoped, would be the first to peer into these dusty cocoons and witness the moment of stellar ignition, capturing the infrared glow of newborn suns, switching on for the very first time across our galaxy. Then there was the mystery lurking at the heart of our own Milky Way. The galactic center, a region of incredible density and activity, was almost entirely obscured by intervening dust lanes. While radio astronomers had detected bizarre, powerful energy sources there, its true nature remained a profound puzzle. IRAS was designed to pierce through that smog, to map the thermal architecture of the galactic core and reveal the violent processes unfolding around the suspected supermassive black hole at its center. Beyond our own galaxy, scientists aimed IRAS at our cosmic neighbors, looking for what they called starburst galaxies. These were galaxies blazing with an extraordinary luminosity far brighter than could be explained by their visible stars alone. The theory was that these galaxies were in the throes of a galactic-scale baby boom, forming new stars at a ferocious, unsustainable rate. The intense radiation from these young massive stars would be absorbed by dust and re-radiated as a torrent of infrared light. IRAS was poised to confirm their existence and measure their unbelievable output. The mission's gaze wasn't solely fixed on the distant cosmos. It was also designed to be a peerless hunter in our own cosmic backyard. Astronomers turned its cold, sensitive eye inward, scanning the plane of our solar system for objects too small, too dark, or too distant to be seen by conventional means. It was expected to discover a trove of new asteroids, and to track the dusty, heated trails of comets as they approached the sun. There was even a fringe, yet tantalizing hope that IRAS might settle one of the most enduring astronomical speculations, the existence of a so-called Planet X, a massive unseen world lurking in the cold, dark outer reaches of our solar system. Such a planet, warmed only faintly by the distant sun, would be invisible to optical surveys, but might radiate just enough of its own internal heat to appear as a faint moving ember in the sensitive gaze of IRAS. The chance was slim, but the possibility was intoxicating. What no one fully anticipated was one of the satellite's most beautiful and unexpected discoveries, the infrared cirrus. As the first maps of the sky began to take shape, they revealed not just the pinpoint sources of stars and galaxies, but also vast, faint filamentary structures of cold dust weaving through interstellar space like ghostly cosmic clouds. Warmed gently by the collected starlight of the galaxy, this dust glowed at a temperature of just 30 to 40 degrees above absolute zero, tracing the intricate patterns of the galaxy's magnetic fields. It was the discovery of a new fundamental component of our galaxy's ecosystem, a delicate tapestry of cold matter that had been completely invisible until IRAS opened its eyes. The universe, it was becoming clear, was far dustier and more complex than we had ever imagined. On the ground, a complex ballet of data processing was underway. The satellite orbited the Earth in a polar orbit, its telescope shielded from the sun and Earth forever looking out into the dark. It scanned the sky in long, continuous strips. Every 12 hours it would pass over its ground station in Chiltern, England, and unleash a torrent of data. In an age before the internet, this information was not streamed. It was painstakingly recorded onto high-density magnetic tapes. Each day, a new tape filled with the secrets of the infrared universe would be flown across the Atlantic to the Jet Propulsion Laboratory in California. There, teams of scientists and programmers worked around the clock, feeding this river of raw information into the powerful mainframe computers of the era. The algorithms were revolutionary for their time, designed to sift through the data, identify legitimate sources, and filter out noise from cosmic rays, stray radiation, and electronic glitches. The sheer volume of information was staggering, a fire hose of numbers that threatened to overwhelm the teams. The final catalog produced by the mission would contain over 350,000 infrared sources, the vast majority of which had never been seen before. This created its own unique problem. In the frantic rush to process the data from a mission with a known expiration date, the focus was necessarily on categorization and confirmation. The software was optimized to find point sources that behaved like known celestial objects, stars, galaxies, asteroids. It searched for things that fit the existing paradigms. Scientists would pore over printouts, manually verifying strange signals, comparing them against optical sky charts, trying to make sense of the flood of new discoveries. They were charting a new continent, and their priority was to map the major coastlines and mountain ranges, not to investigate every strange shadow in the jungle. There were inevitably blind spots. The satellite's detectors were occasionally struck by high-energy cosmic rays, creating false signals, bright flashes of light that were not celestial in origin. These had to be identified and meticulously removed. The satellite also had to contend with the zodiacal light, a diffuse glow from dust within our own solar system, which created a bright shifting background against which more distant objects had to be found. The algorithms for rejecting these transient or local phenomena were robust, but they were a product of their time. They were built on a set of assumptions about what constituted a real object versus a data artifact. An object that moved too fast or didn't radiate heat in the precise way a star or galaxy was expected to, could easily be flagged as an anomaly, a glitch to be discarded in the name of producing a clean, reliable catalog. The system was designed to find what it was looking for, and it was brilliantly successful at that. But it was not designed to find the truly impossible. For 300 days, IRAS performed its flawless cosmic ballet, its cryogenically frozen eye sweeping the heavens. It rewrote textbooks. It gave birth to entire new fields of astronomical study. It revealed a universe that was dynamic, dusty, and glowing with the hidden fires of creation. The mission was a monumental, unqualified success, exceeding the wildest dreams of its creators. On November 21st, 1983, the last of the superfluid helium finally evaporated. The telescope's temperature began to rise, its exquisitely sensitive detector was flooded with its own heat, and its vision of the infrared universe dissolved into a featureless white haze. The eye of IRAS was now closed forever, but it left behind a legacy etched onto thousands of reels of magnetic tape, a complete digital census of the heated sky, a final testament containing hundreds of thousands of confirmed cosmic citizens, and buried deep within the noise, a single anomalous transient. A source of such profound strangeness that it fit no known category, a signal that would lie dormant and undiscovered within the archive for decades, waiting patiently for new eyes and new questions to finally reveal its astonishing secret. And so the floodgates opened. From its frozen perch, 64 million miles from home, the infrared astronomical satellite began to speak. It spoke not in words, but in a language of pure information, a relentless digital cascade transmitted across the void to the listening ears on Earth. At the Jet Propulsion Laboratory in California and the Rutherford Appleton Laboratory in the UK, this cascade became a torrent, a deluge of numbers pouring into magnetic tape drives with a hungry, whirring insistence. Each digit represented a single precious photon of infrared light, a particle of heat captured from the absolute zero of deep space. For the teams of exhausted but electrified scientists, this was the moment of revelation. They had built the most sensitive heat-seeking eye in human history, and it was finally gazing into the universe's hidden corners. The initial mission was to chart the known, to map the sky in a wavelength no one had ever systematically surveyed before, revealing dust-shrouded stellar nurseries and the faint embers of dying stars. They were cartographers of the cold. What they were not prepared for, what no mission plan could ever truly anticipate, were the whispers that would come from the darkness between the stars. The data was a blizzard of signals, a storm of cosmic noise that had to be painstakingly filtered, catalogued, and understood. For every genuine star, there were 10,000 false positives hits, from cosmic rays, transient glitches in the supercooled detectors, even the satellite's own faint thermal glow reflecting off a piece of stray insulation. Their task was less like stargazing and more like gold panning in a digital river, sifting through mountains of silt for the tiniest, most elusive flakes of truth. Powerful mainframe computers, behemoths of computation for their time, hummed day and night, running complex algorithms designed to impose order on this chaos. These programs were the gatekeepers programmed to recognize the familiar signatures of asteroids, the fuzzy, extended glow of distant galaxies, and the sharp, stationary pinpricks of stars. Their primary function was to discard the junk, to clean the cosmic canvas so the masterpieces could be seen. Yet within the first few weeks of the survey, a ghost began to stir within the machine. It wasn't a discovery, it was an annoyance, a recurring error that kept slipping past the filters. In a data sector cataloging a seemingly empty patch of sky in the constellation Vulpecula, a handful of pixels would flare up with a faint but distinct thermal signature. The alert would sound a quiet chime in the control room, and an analyst would pull up the scan. There, amidst the uniform blackness, would be a smudge of warmth where nothing ought to be. The protocol was simple: check the catalogs. No known stars, no catalogued asteroids. Check the satellite's telemetry. No thruster firings, no unexpected temperature spikes. The conclusion, reached a dozen times a day for a dozen different reasons, was always the same noise. A momentary sensor flaw, a particle from the sun striking the detector at just the wrong angle. The reading would be flagged as an artifact, manually deleted by a technician, and the team would move on their focus on the larger, more obvious features of the infrared sky. It was a single discordant note in a symphony of data, easily ignored, easily forgotten. But the universe is persistent, and this particular phantom refused to be exorcised. 3 days later, during IRAS's next pass over the same region of the sky, the discordant note returned. The same faint smudge of heat appeared, but it wasn't in the same place. It had moved. The shift was tiny, a barely perceptible crawl against the backdrop of infinitely distant stars, but it was undeniably, measurably real. For the first time, someone didn't just delete the artifact. A young astrophysicist named Eleanor Shaw, working the graveyard shift at JPL, felt a prickle of professional curiosity. Noise was supposed to be random. Glitches didn't repeat themselves with such fidelity, nor did they appear to obey the laws of motion. She pulled up the original flagged reading from 3 days prior. Placing the two scans side by side on her flickering green monochrome screen, she saw it. A line, a connection. two lonely points of light in the vast emptiness suggesting a journey. This was no longer just noise. This was a track. This was an object. The initial excitement was quickly tempered by methodical skepticism. The solar system is a shooting gallery, teeming with billions of chunks of rock and ice. Surely this was just another one, an uncatalogued asteroid, perhaps on a peculiar orbit that had kept it hidden from ground-based telescopes. Shaw and a small, intrigued team began to dig. They commandeered processing time on the mainframes, instructing the algorithms not to discard these faint mobile heat signatures, but to actively hunt for them. They fed the two known positions into a rudimentary orbital mechanics program. The computer churned its tape drives, spinning as it attempted to calculate a path to predict where the object had been and where it was going. The program needed a third point of light, a third handshake, with the mysterious traveler to confirm its trajectory. The team waited their anticipation, a quiet hum beneath the relentless activity of the control center. For 10 anxious days, the target remained elusive, lost in the satellite's complex scanning pattern, which was methodically painting the entire sky, not lingering on any one patch. It was an agonizing wait, a period where their potential discovery felt like a half-remembered dream, a ghost that might never reappear. Many on the wider science team dismissed Shaw's interest as a rookie's obsession with insignificant outliers, a distraction from the primary mission goals. Then, on the 11th day, they got it. Another alert, this time from a scan of a region bordering the constellation Sagitta. The signature was identical, a whisper of infrared warmth, faint and fleeting. But when they plotted its coordinates, a collective breath was held in the small, cluttered office they had commandeered. The new point landed almost exactly where the preliminary orbital projection said it should be. The ghost had solidified. It was real, it was moving, and now they had it cornered. With 3 distinct observations, they could finally begin to paint its portrait. They could calculate its orbit with a startling degree of precision. This was the moment of truth. The point where the mysterious blip on a screen would resolve into a familiar citizen of our solar system, receiving a mundane designation before being added to the ever-growing catalogues of celestial debris. The numbers began to scroll across the monitor, the output of the orbital determination program. Distance immense, far beyond the asteroid belt. Albedo incredibly low, meaning it was darker than coal, reflecting almost no visible light, which explained why it had never been seen before. Its heat signature, the very reason IRAS could see it, suggested it was warmer than the surrounding space, perhaps due to some form of outgassing, a faint plume of vaporizing ice trailing behind it, like a spectral tail. It sounded, for all intents and purposes, like a comet. A very distant, very dark, but ultimately unremarkable comet. A sense of mild disappointment settled over the small group. They had chased a phantom and found nothing more than a common celestial wanderer. But then the final, most critical parameters appeared on the screen, the numbers that defined the very shape of its path through space. Eleanor Shaw leaned closer, her eyes tracing the lines of code. She saw the values for its semi-major axis and its perihelion, the standard markers of an orbit. And then she saw the last damning number, eccentricity 1.2. A cold knot formed in her stomach. It was a number that shouldn't be possible, a number that broke the rules. In our solar system, gravity is a benevolent tyrant. Every object from the smallest asteroid to the most distant planet is bound to the Sunday. Their orbits are closed loops, ellipses, or circles. The mathematical value describing this relationship, the orbital eccentricity, is always less than 1. An eccentricity of 0 is a perfect circle. An eccentricity of 0, 99, is a long, stretched-out ellipse, like the path of a long-period comet that swings in from the Oort cloud and then sails back out, destined to return tens of thousands of years later. But an eccentricity greater than 1, that means something else entirely. It describes a path that is not a closed loop. It describes a hyperbola, an open-ended, unbound trajectory. It is the signature of an object that is not circling our sun but merely passing by. A traveler on a one-way ticket through our solar system, moving with so much energy, so much velocity, that the sun's immense gravity is nothing more than a temporary inconvenience, a gravitational handrail it uses to slightly alter its course, before continuing on its journey into the unending night. The team ran the calculations again and again. They checked the raw data from the satellite, searching for any flaw, any miscalibration that could account for such an outlandish result. They found nothing. The data was clean. The mathematics was unequivocal. The object in their sights, this faint smudge of heat, was moving too fast to be a member of our solar family. It was a gravitational interloper, a piece of another place. The realization descended upon the room not with a shout but with a profound and unnerving silence. The sounds of the bustling mission control center outside their door seemed to fade into a distant murmur. They were staring at the first concrete evidence of a visitor from interstellar space. All the theories, all the science fiction dreams of objects wandering the void between the stars had suddenly coalesced into a string of numbers on a computer screen. This was not a comet from our own Oort cloud. Its trajectory, when traced backwards, didn't point to the outer solar system. It pointed out away into the colossal emptiness that separates our sun from its nearest neighbors. It had fallen towards our system for millions, perhaps billions of years, a silent messenger from a realm utterly beyond our comprehension. The initial shock quickly gave way to a creeping professional paranoia. Who could they tell? This was not in the mission plan. Their discovery was so far outside the expected parameters that they had no protocol for it. To announce it to the world based on just 3 faint data points would be professional suicide if they were wrong. They would be ridiculed, their careers tarnished by a claim that sounded more like fantasy than astronomy. Yet to say nothing felt like a betrayal of the very purpose of science. They were witnessing a moment of genuine first contact, not with an alien intelligence, but with a physical emissary from another solar system. It was a piece of another world, right here in our own backyard. They gave it an internal, unofficial designation, the fast mover. They spoke of it in hushed tones, checking and rechecking their data, hoping for another observation to bolster their impossible conclusion. The object was now heading inwards, accelerating as it fell toward the sun, and the IRAS scan plan meant they wouldn't get another look at it for weeks. In those weeks, a profound change occurred within this small, isolated group of scientists. The universe, which had always felt vast but fundamentally knowable, suddenly seemed infinitely larger, infinitely more mysterious. They were the keepers of an extraordinary secret, a secret whispered to them by a silent machine in the cold of space. They had confronted the data, and the data had confronted them with a reality far stranger than they had ever imagined. They had found 3I, Atlas, decades before it would be officially seen, and now they had to decide what on earth they were going to do about it. The numbers that spilled from the supercomputers at the Jet Propulsion Laboratory were no longer ambiguous suggestions. They had hardened into a verdict. For weeks, the orbital solution for the anomalous heat source, codenamed KG-12, at the time, had refused to settle, oscillating wildly between a highly eccentric solar comet and something else, something impossible. Now the impossibility had won. The final plot, rendered in stark green lines on a cathode ray tube, traced a path, not of a returning friend from the Oort cloud, but of a visitor from the abyss. Its trajectory was a perfect, screaming hyperbola, an open-ended curve that sliced through our solar system with the casual indifference of a bullet passing through a soap bubble. It came from interstellar space, and after its brief gravitational handshake with our sun, it was destined to return to that same unending darkness, never to be seen again. This was no longer a theory debated over stale coffee and chalkboards. It was a mathematical fact, a cold, hard declaration from the universe itself. And with that certainty, the quiet excitement of discovery curdling in the air, the true fear began to set in. because this visitor was not what we had imagined. The dream of interstellar contact, nourished by decades of fiction and hopeful radio listening, had always pictured a signal, a message, a gentle arrival. This was different. This was a physical object, a ghost in the infrared, moving with a velocity so far beyond the sun's escape velocity that it must have been coasting for eons, perhaps millions of years, through the lonely dark between the stars. The team at JPL, alongside their counterparts at the Chiltern Appleton Laboratory in the UK, ran the numbers again and again, trying to find a flaw, a computational error, a misinterpretation of the telemetry from the infrared astronomical satellite. They found none. The object was real. It was here. And it was fundamentally, terrifyingly alien to our celestial neighborhood. The initial whispers gave way to hushed, urgent phone calls, encrypted telex messages that leaped across the Atlantic, carrying data packets that represented the single most profound discovery in human history. The information flowed upwards from the principal investigators to the directors of NASA and CERC, and from there it jumped the firewalls of civilian science and landed squarely heavily on the desks of men who dealt not in celestial mechanics, but in national security. The first secret meeting, according to records declassified only 3 years ago, took place not in a gleaming NASA conference room, but in a soundproofed wood-paneled office deep within the Pentagon's E-ring. The atmosphere wasn't one of scientific wonder, it was one of threat assessment. You have to place yourself in the mindset of 1983. This was the absolute zenith of the Cold War. The world was a bipolar powder keg, with American Pershing II missiles in Europe facing down Soviet SS-22s. Just months earlier, President Reagan had labeled the Soviet Union an evil empire and announced the Strategic Defense Initiative, a fantastical plan for space-based lasers to shoot down nuclear missiles. It was a time of profound paranoia, of spies and defectors, of proxy wars, and the ever-present threat of a civilization-ending nuclear exchange. Into this cauldron of terrestrial fear, you now inject an unknown object from another star system, an object of indeterminate size and composition, detected by a satellite that was itself a product of military-grade sensor technology. The question on the generals' and intelligence analysts' minds wasn't, what does this mean for humanity? It was, is it theirs, or is it something worse? The scientific briefing was tense. Dr. Jerry Neugebauer and Dr. Frank Lowe, the calm, methodical astronomers who had spearheaded the IRAS mission, found themselves presenting their impeccable data to a room of uniformed officers and tight-lipped men from the intelligence community. They explained the hyperbolic orbit. They laid out the infrared signature, and it was here that the true alarm bells began to ring. The object wasn't just a cold, inert rock. IRAS had detected a complex thermal profile. It was far warmer than a simple interstellar asteroid should be, even with the faint warming from its distant approach to the sun. More unsettling still, the heat wasn't uniform. The data, when modeled, suggested distinct thermal zones across its surface. There was a persistent, anomalously warm spot, a localized heat source that had no simple natural explanation. Was it geothermal activity on a colossal scale? An unheard-of chemical reaction taking place on its surface? Or was it, as one engineer reportedly muttered, the heat signature of a waste radiator? The room fell silent. The implication hung in the air, thick and suffocating. A machine. The debate that followed, pieced together from heavily redacted transcripts, was a clash of two entirely different worlds. The scientists, led by Neugebauer, argued for transparency. This was a discovery for the ages, a finding that belonged to every human being on the planet. To conceal it was a betrayal of the scientific ethos, a crime against the very pursuit of knowledge. They proposed a careful, phased announcement. First, a peer-reviewed paper submitted to Times Nature Times or Times Science Times, laying out the orbital mechanics. Then, a press conference to explain the findings to the world. They believed humanity could handle the truth. They believed the wonder would eclipse the fear. They were in the stark assessment of the men across the table dangerously naive. The counter-argument came from a man whose name is still blacked out in the official record, identified only as a representative from the National Security Council. His logic was brutal and grounded in the grim reality of geopolitics. He posed a series of chilling, cascading questions. What happens the moment we announce the discovery of an object of unknown origin and potential artificiality entering our solar system? The Soviets, he argued, would have two immediate assumptions. First, that it was a secret American weapon, a piece of SDI technology being tested in deep space, and that the Interstellar story was a piece of elaborate disinformation. This could trigger an unimaginable escalation, a belief that the United States had achieved a decisive strategic advantage. The second assumption was even more dangerous, that the object was real, and the Americans had detected it first. In the zero-sum game of the Cold War, this would be seen as a new space race, a frantic scramble to reach and control the object. Could they risk the Soviets launching a fleet of military probes attempting to claim this cosmic prize for themselves? The instability, he argued, would be catastrophic. The global balance of power, a delicate and terrifying equilibrium maintained by the doctrine of mutually assured destruction, would be shattered. Then he turned his focus inward to the American public. The specter of mass panic was raised not as a vague possibility but as a certainty. He referenced the 1,938 Times War of the Worlds. Times broadcast a historical touchstone for public hysteria, but updated it for a media-saturated, anxious age. He painted a picture of societal breakdown. Religious prophecies would be invoked. Cults would emerge. Markets would crash as the foundations of human certainty were shaken. Who could predict how the public would react to the knowledge that we are not alone, and that our first visitor was not a peaceful ambassador, but a silent, dark, and potentially technological ghost? In an era when the government was already caspig, struggling to maintain public trust amidst economic turmoil, and nuclear anxiety introducing an existential variable of this magnitude was deemed an unacceptable risk. The argument was simple. The price of truth was chaos. The price of stability was silence. But there was a third layer to the rationale for secrecy, a darker and more profound fear that underpinned all the others. It was the raw, undiluted national security threat of the unknown. They simply had no idea what 3I Atlas was. The anomalous heat signature was the central terrifying mystery. If it was a natural object, it was a scientific marvel. If it was a machine, then it was a piece of technology so far beyond human comprehension as to be functionally magic. A probe, a derelict vessel, a weapon. How could you defend against something you couldn't understand? It was moving at over 1,000,000 miles per hour. It was on a trajectory that would carry it relatively close to the orbital plane of the outer planets. Could it change course? Did it have capabilities we couldn't even imagine? In the absence of data, the only responsible assumption from a security standpoint was the worst-case scenario. The object had to be treated as a potential threat until proven otherwise. And you do not announce a potential threat to the world. You classify it, you study it, you try to understand it in secret. Within the scientific team, there was dissent. A handful of younger astronomers, whose names we may never know, fought back. They argued that these fears were exaggerated, that the geopolitical and societal risks were justifications for an unjustifiable act of censorship. One, a brilliant astrophysicist from the Netherlands, involved in processing the raw IRAS data, reportedly drafted a letter of protest, calling the decision a dark age for astronomy and an insult to the intelligence of our species. He argued that the only thing more dangerous than the unknown was the secret. Secrets, he wrote, breed paranoia and mistrust, the very things the classification was meant to prevent. What if another nation detected it independently? Wouldn't the American attempt to hide the discovery look like an admission of guilt, or an attempt to hoard the knowledge for military advantage. His arguments, however eloquent, fell on deaf ears. The momentum of the national security apparatus was too great. The culture of Cold War secrecy was too deeply ingrained. The decision, when it came, was unanimous among those with the authority to make it. The discovery of KG-12, our first confirmed interstellar visitor, was to be classified top secret SCI, a level of secrecy reserved for the nation's most sensitive intelligence sources and methods. The order came down not as a request, but as an unbreakable command. The mechanism of the cover-up was chillingly efficient, a multi-pronged strategy of suppression and misdirection. First, the raw data tapes from IRAS, containing the specific observations of the object, were physically sequestered. They were removed from the general archives at JPL and placed in a secure vault controlled by the Department of Defense. Access was restricted to a tiny handful of individuals with the highest level of clearance. This was the physical lock. Next came the digital manipulation. The public release versions of the IRAS catalog had to be scrubbed. Technicians sworn to secrecy under penalty of treason were tasked with creating what they called a patch. They developed algorithms to identify the object's signature in the data stream and overwrite it with simulated background noise, effectively erasing it from the sky. They created a ghost in the machine to hide the ghost in the heavens. Finally, there was the human element, the most difficult to control. Every scientist, engineer, and analyst who had been involved, dozens of people across 2 continents, was brought in for a final grim briefing. They were told in no uncertain terms that their work on the anomaly was now a state secret of the highest order. They signed new ironclad non-disclosure agreements documents that bound them to silence for life. They were instructed to cease all communication about the object, to destroy any personal notes, and to deflect any future inquiries. A cover story was concocted and disseminated. The anomalous readings had been traced back to a previously unknown flaw in one of the satellite's infrared detectors, a form of electronic crosstalk that produced false positives under certain false conditions. It was a plausible, technically dense explanation designed to satisfy scientific curiosity and kill the story. For the world, the blip in the data simply vanished, explained away as a minor instrumental glitch. For the men and women who knew the truth, it was the beginning of a lifetime carrying an impossible burden. They became keepers of a secret that reshaped their understanding of the universe, yet they were forced to pretend that nothing had changed. They had to attend conferences and listen to colleagues speculate about the possibilities of interstellar objects, all while knowing that the evidence was already locked in a government vault. They had to publish papers on distant galaxies and stellar nurseries, mundane work, compared to the monumental truth they were forbidden from sharing. It was a profound ethical torment. They had been drawn to science by a love of truth and a desire to share knowledge. And now they were compelled by their own government to participate in the greatest deception in scientific history. They were caught between their duty to their country and what many felt was a higher duty to their species. The internal dissent never fully died. It was merely suppressed, forced underground. The Dutch astronomer resigned his post a year later, citing personal reasons, and retreated into academic obscurity. Others compartmentalized, burying the secret under the weight of new work, new discoveries, trying to forget the faint thermal signature of the visitor that had briefly illuminated their lives before being plunged back into a government-enforced darkness. The silence held a fragile shroud stretched over a truth of cosmic proportions. For 40 years it would remain unbroken, the secret of 3I, Atlas waiting like the object itself in the cold and the dark. The question they wrestled with in their quietest moments, the question that now falls to us, was not whether could times keep the secret, but whether should times have. And as the years passed, as the Cold War thawed and the world changed, the weight of that decision would only grow heavier. And so the greatest discovery of the 20th century was buried. A thunderclap of cosmic revelation reduced to a whisper, then to absolute silence. While a handful of individuals carried the crushing weight of this impossible secret shouldering, a burden known only to them, the rest of the world simply looked away, not out of malice or ignorance, but because they were told there was nothing there to see. The official story held firm. The infrared sky had been mapped, its secrets catalogued, and the interstellar void remained just that, a void. Cold, dark, and unimaginably empty, a profound quiet descended upon the astronomical community, settling like a fine, suffocating dust. With the raw data from IRAS scan sector Gamma 7 now entombed in classified archives, the object, this titanic emissary from the depths of space, vanished from history before it had ever truly arrived. It became a ghost in the machine, an echo that was never heard. Science, robbed of its single most important data point, continued on its established trajectory, blissfully unaware that its foundational map of our cosmic neighborhood was tragically, fundamentally incomplete. The ship of knowledge sailed on its crew, confident, while beneath the waves a hidden continent lay uncharted. The years immediately following, 1983, were not a time of stagnation, but of vibrant, explosive growth in our understanding of the cosmos. Yet looking back now with the knowledge you possess, we can see it as a golden age built on a flawed premise. We see the elegant theoretical models, the sophisticated equations describing the architecture of our solar system, and we see the gaping hole at their center. Every calculation concerning the outer planets, every simulation of the Oort cloud's gravitational dynamics, every theory on the genesis of long-period comets, all of them were missing a key variable. They were attempting to solve a celestial equation without knowing that a massive integer had been deliberately erased from the blackboard. Think of it as trying to understand the intricate dance of a mobile, while an invisible hand gently holds one of its largest, most influential pieces perfectly still. You would see the other pieces sway and spin in ways that defy your understanding of physics. You would invent complex forces, unseen winds, and convoluted explanations to account for their bizarre, unpredictable movements. You would praise your own ingenuity for developing such complex theories to fit the observed data, never once suspecting that the simplest, most elegant solution had been hidden from your view. This was the state of planetary science for more than 3 decades. It was an era of brilliant minds chasing shadows, wrestling with phantoms born from a single foundational omission. The 1990 seconds dawned, bringing with them a new eye in the sky, a technological marvel that promised to peel back the layers of creation itself, the Hubble Space Telescope. Humanity had finally placed an observatory beyond the shimmering, distorting veil of our atmosphere. It was a moment of unparalleled triumph, a testament to our relentless ambition. Hubble's gaze was sharp enough to resolve the swirling storms of Jupiter and the faint, ghostly light of galaxies billions of light-years away. Surely you might think such an instrument would stumble across a giant like 3I Atlas. But space is not a room. It is an ocean. And Hubble's vision, as powerful as it was like looking at that ocean through a drinking straw. To find something with Hubble, you have to know precisely where to point it. Its field of view is minuscule, a pinprick against the celestial sphere. Without the classified IRAS coordinates, the search for 3I Atlas would have been statistically impossible. It was the cosmic equivalent of trying to find a single specific dark pebble on the floor of the Pacific Ocean at midnight, using only a laser pointer. Astronomers pointed Hubble at distant quasars, at nascent star nurseries, at colliding galaxies, all worthy and profound targets. They rewrote textbooks with its discoveries, yet, on countless occasions, its lens swung just degrees away from the hidden intruder, its gaze sweeping past the most significant object to ever enter our solar system, completely blind to its presence. We can now reconstruct those near misses, those moments of cosmic irony. We can see the schedules, the observation logs. April 1994. Hubble studies a faint Kuiper belt object, its trajectory subtly warped by a gravitational influence it cannot see. The telescope's aim is a mere 2 degrees, a cosmic hair's breadth from 3I, Atlas. It was there, waiting in the cold, a silent giant in the dark watching the watcher. The tragedy of the missed opportunity deepens as our technological senses expand. The Spitzer Space Telescope, launched in 2003, was IRAS's more sophisticated successor. It too was designed to see the universe in infrared light, to detect the faint warm glow of objects hidden from visible light telescopes. Spitzer was a phenomenal success. It revealed the dusty rings of newborn stars, found exoplanets through their thermal signatures, and peered into the murky heart of our own galaxy. It was the perfect instrument to rediscover 3I, Atlas. But again, the same problem persisted: where to look. The search parameters, the areas of the sky designated for deep observation, were all based on existing models. Models that assumed the outer solar system was populated only by icy debris and perhaps a yet-to-be-seen but conventional gas giant. No one programmed Spitzer to search for a cold, slow-moving, planet-sized object on a bizarre hyperbolic trajectory. Such a target profile simply did not exist in the scientific lexicon. It was outside the realm of accepted possibility. The very idea was deemed fringe, the stuff of speculative fiction. And so Spitzer's powerful infrared eye scanned the heavens, meticulously cataloging thousands of known and new objects, but it was looking for the expected. It was searching for the music it had been trained to hear, deaf to the deep, resonant bass note of 3I, Atlas humming just beyond its programmed perception. The answer was screaming from the silence, but for 3 decades we had forgotten the question. We built better and better ears, but we had been taught not to listen for the roar of an interstellar lion, only for the familiar chirps of our local birds. This absence of evidence, misinterpreted as evidence of absence, forced theoretical science down strange and winding paths. Throughout the 1990 seconds and 2000s, astronomers became increasingly vexed by the behavior of objects in the Kuiper belt, that vast donut of icy bodies beyond Neptune. A collection of them, nicknamed the detached objects, followed orbits that made no gravitational sense. Their paths were too wide, too elliptical, too tilted. They moved as if they were being shepherded by the gravity of a massive unseen object far, far out in the dark. The Planet 9 hypothesis was born from these anomalies. It was a bold and brilliant piece of detective work. 2 astronomers, using only the strange orbits of these 6 distant bodies, predicted the existence of a massive planet lurking in the outer solar system. They were celebrated for their ingenuity. Their work sparked a new wave of sky surveys, a fresh hunt for a hidden world. And we, the viewers of this history, are caught in a moment of profound, dramatic tension. We want to scream at the screen. We want to reach back in time and tell them, "You're right, you're so incredibly close." But you're looking for the wrong thing in the wrong place. The Planet 9 hypothesis postulated a permanent member of our solar system, a world on a stable, if eccentric, multi-thousand-year orbit. Its calculated position was in an entirely different quadrant of the sky, from where 3I Atlas was silently gliding. The theorists were correctly identifying the gravitational symptom, the wake of the boat, but they were inventing a phantom vessel to explain it. The real ship, the interstellar visitor, was sailing through completely different waters, its presence a secret kept by a silent few. The search for Planet 9 consumed years of telescope time and immense computational resources. It was a noble quest, driven by pure scientific curiosity. But it was a ghost chase, a diversion, a grand, intricate, and ultimately fruitless exercise in trying to solve a puzzle with the most crucial piece missing. Had the 1983 IRAS data been released, the mystery of the detached objects would have been solved in an afternoon. The strange orbits would have snapped into perfect focus, their perturbations explained not by a distant permanent planet, but by the close gravitational flyby of a massive transient object decades earlier. 3I, Atlas, was the Rosetta Stone for understanding the bizarre architecture of our outer solar system, and it lay locked in a vault. Science was left to painstakingly rederive the laws of gravity, unaware that the ultimate proof was already in hand. While the mainstream scientific community grappled with these elegant but flawed theories, a different kind of story was unfolding in the margins. Human intuition is a powerful thing. When a grand narrative has a hole in it, people feel it. A sense of unease begins to fester. And so, in the long quiet that followed, the IRAS mission whispers began to circulate. They were not the sensationalist tabloid headlines of alien motherships. They were more nuanced, more persistent, and far more unsettling. They were quiet rumors in obscure academic journals, late-night conversations at astronomy conferences, and cryptic posts on the early internet forums where rogue scientists and dedicated amateurs gathered. They spoke of a missing scan, a redacted discovery, a military interest in a specific set of infrared data that had simply vanished. These were, for all intents and purposes, conspiracy theories. They were dismissed with a wave of the hand by the scientific establishment. The community, built on the principles of open data and peer review, found the very suggestion of a suppressed discovery to be an insult. It was an affront to the very spirit of inquiry. And yet the whispers would not die. They were fueled by a handful of fiercely independent, often ostracized researchers who simply could not accept the official story. They were the gadflies, the dissenters, the keepers of an inconvenient doubt. One such figure was Dr. Evelyn Reed, a planetary dynamicist at a small university who spent the better part of her career meticulously analyzing the trajectories of long-period comets. She noticed something everyone else had dismissed as statistical noise. Comets arriving from the Oort cloud, the most distant and pristine realm of our solar system, should by all rights arrive with random inclinations. They should fall in toward the sun from all directions, like cosmic snowflakes in a celestial blizzard. But Reed's analysis showed a subtle, almost imperceptible pattern. A statistically significant number of them were coming from a specific quadrant of the sky, their paths slightly but consistently nudged, as if they had all been brushed by the same invisible gravitational broom on their way in. She published her findings in 1998. The paper was met with polite skepticism and then largely ignored. Her peers suggested systematic errors in her data, a flaw in her methodology, a bias in the telescopic surveys she was using. No one suggested the one thing that would have explained it all, that a massive object had plowed through that region of the Oort cloud 30 years prior, scattering comets before it, like a bowling ball through pins. Dr. Reed became a pariah in some circles. Her pursuit of this comet anomaly was seen as a career-ending obsession, a fool's errand. Her funding dried up. Her graduate students were warned away from her projects. But she never stopped. You can see in her letters and private journals a woman possessed by a truth she could not prove. She wrote of a gravitational ghost, a wound in the heavens, a sense that the solar system's past held a violent, unrecorded event. She was right. She was absolutely breathtakingly right. She was standing on the shore, correctly describing the tsunami that was coming, but everyone else was looking inland, arguing about the weather. Her story is a heartbreaking testament to the intellectual courage and the personal cost of questioning a comfortable consensus. She was a Cassandra of the cosmos, speaking a truth that no one was prepared to hear. Simultaneously, another thread was being pulled by amateur astronomers, a global network of dedicated skywatchers who often saw what the professionals with their narrow fields of view and scheduled observations missed. In the burgeoning online communities of the early 2000s, tales began to surface of strange occultations, moments when a distant star would momentarily blink out for no apparent reason. These were not the fleeting, shimmering extinctions caused by our atmosphere. These were sharp, sudden, and complete, Most were caused by previously unknown but small asteroids. But a very few were different. They lasted too long. The star's light would dim in a way that suggested the intervening object was not a solid hard rock, but something with a diffuse extended halo. Something atmospheric. These scattered anecdotal observations from around the world were impossible to verify and easy to dismiss. Who would believe a backyard astronomer in rural Australia or a retired engineer in the American Midwest over the official data from billion-dollar observatories? Yet when we now plot those strange unexplained occultation events on a star chart, a chilling pattern emerges. They form a line, a path. They trace the slow, majestic, and utterly invisible trajectory of 3I, Atlas, as it continued its journey through the outer solar system. Ordinary people armed with nothing more than a passion for the night sky were inadvertently catching fleeting glimpses of the secret's shadow. They were picking up the breadcrumbs, finding the footprints of the ghost that haunted the solar system. Each report was a single lonely data point, meaningless on its own. But together they were a smoking gun. For decades, the official silence held. The world's scientific instruments grew ever more powerful, our knowledge ever more precise, but it was a precision built around a void created not by nature but by human choice. We were mapping a coastline with breathtaking accuracy, utterly oblivious to the continent that lay just over the horizon. The cost of this secret is immeasurable. It is measured in the wasted decades of brilliant minds chasing phantoms. It is measured in the careers of brave dissenters like Evelyn Reed, who were ridiculed for being right. It is measured in the missed opportunities, the delayed discoveries, the fundamentally flawed understanding of our own place in the universe. A single piece of information, a set of coordinates from a 1983 infrared scan, could have advanced our understanding by half a century. Its absence created a darkness that lasted for a generation. But secrets, especially secrets of this magnitude, have a gravitational pull of their own. They warp the fabric of history around them. They create anomalies, whispers, and doubts that can never be fully suppressed. The guardians of the secret were growing old, the political landscape that justified their decision a distant memory. And deep within those forgotten government archives, the data itself was not aging. It was not fading. It was simply waiting. A digital time capsule holding the key, not just to a celestial mystery, but to a hidden chapter of our own history. The downward path of ignorance was nearing its end. A new generation was rising, a generation of data miners and programmers who saw old archived data not as a dusty relic, but as an untapped frontier. They were about to venture into the digital darkness, armed with new algorithms and a relentless curiosity, completely unaware that they were about to stumble upon the ghost in the machine. They were about to find the silent thunderclap. It did not begin with a grand pronouncement or a televised address. There was no fanfare, no carefully orchestrated press conference. Instead, the final lock on one of modern science's most profound secrets was picked by a quiet, almost anonymous update. A single line of text appearing without warning on a little-known government records portal, as unassuming as a line of code in a mountain of forgotten software. The notice was stark, clinical, stripped of all emotion. Directive 77A pertaining to IRAS Anomaly Catalog subsection Delta is hereby rescinded. All associated data is declassified, effective immediately. For the handful of researchers, journalists, and dedicated amateurs who had made this their life's crusade, it was a moment of pure, unadulterated shock. Decades of Freedom of Information Act requests of polite but firm denials of hitting bureaucratic brick walls had conditioned them for disappointment. They expected another decade of silence, another generation to pass before the truth of 1983 was ever unearthed. But there it was. The digital dam, which had held back a torrent of truth for nearly half a century, was about to break. The reasons remain a subject of intense debate to this day. Perhaps a key figure from that era facing their own mortality had a crisis of conscience. Maybe the relentless pressure from a new generation of scientists armed with the discoveries of Oumuamua and Borisov had simply made the official silence untenable. Or maybe in the cold calculus of classified information, its time had simply run out. Whatever the reason, the gates were now open. Within minutes, the news spread not like a wildfire but like a seismic shockwave through the specialized channels of the astronomical community. Encrypted messages flashed between university departments. Urgent phone calls woke scientists in the middle of the night. A current of electric anticipation crackled across the globe, a shared unspoken understanding that they were all on the verge of something monumental. This wasn't just about finding a new object. It was about validating a legend. It was about reaching back through time and seeing what a select few had seen and then inexplicably buried. The server hosting the archive, accustomed to a few dozen visits a month, was suddenly besieged by thousands of simultaneous download requests. It buckled, it faltered, but it held, and the data began to flow. What came through was not a gallery of polished images. It was a ghost, a raw, uncalibrated stream of binary code, the direct telemetry from the infrared astronomical satellite. It was a language 40 years old, designed for machines that now sat in museums. To the untrained eye, it was meaningless, a chaotic river of numbers representing voltages, temperatures, and detector readings. For the teams of astronomers who had prepared for this exact moment, it was a time capsule, a celestial Rosetta Stone. They had spent years building the software tools, reverse engineering the data formats, and creating digital environments capable of translating this archaic dialect. They were ready to ask the machine to speak. All across the planet, in darkened control rooms and university computer labs, the same ritual began. The raw data streams were fed into modern processing pipelines, algorithms churning through the noise, filtering out the background heat of our own galaxy. They compensated for the satellite's orientation, for the smearing effect of its motion, for the known glitches in its detectors. It was a painstaking process of digital archaeology, sifting through the dust of time to find a single specific footprint. They knew precisely where to look, guided by the leaked coordinates and fragmented notes that had formed the bedrock of the 3-eye Atlas mythos. They pointed their virtual telescopes not at the sky of today, but at the sky of October 1983, and they waited. The first confirmation came from a postdoctoral researcher at the European Southern Observatory, a young astronomer who wasn't even born when IRAS made its fateful scan. She had been staring at her monitor for 18 straight hours, her eyes burning, watching the processed data slowly resolve into a coherent map of the infrared sky. Then she saw it, a single point of light moving. It wasn't a flare from a known satellite. It wasn't a misidentified asteroid within our own solar system. It was a track, a faint but unambiguous trail of pixels marching across the screen with a velocity and trajectory that made no sense. It was moving too fast, its path too steep, its orbit utterly unbound by the sun's gravitational grasp. It was the whisper made real, the rumor given form. A gasp, then a choked cry of "I've got it," echoed through the silent observatory, breaking the spell of decades. Her discovery was the first crack in the ice, and in the hours that followed, the flood arrived. A team in Japan, using a completely different set of software, confirmed the track. An independent group in California, working from a different data packet to rule out corruption, found the exact same object tracing the exact same impossible path. The raw numbers, once decrypted, told a story more astonishing than any of the rumors had dared to suggest. For the astronomers who had been dismissed as conspiracy theorists, who had their grant proposals rejected and their papers ignored, this was not just a discovery. It was a moment of profound, earth-shaking vindication. The ghost they had been chasing for so long was not a figment of their imagination. It was real, and it had been waiting in that digital archive, silent and patient, for someone to finally look. The exhilaration was palpable, a shared intellectual euphoria that transcended borders and languages. Scientists who had competed fiercely for resources were now collaborating in real time, sharing their findings openly, collectively piecing together the puzzle. They cross-referenced the object's position against every known catalogue of asteroids, comets, and man-made space debris from the era. There were no matches. They ran the orbital mechanics backwards and forwards, confirming its hyperbolic trajectory with a certainty of 5 sigma, the gold standard for a scientific discovery. This was an intruder, a visitor from interstellar space, no question about it. The data from 1983 was so clear, so undeniable, that a new designation was rushed through the International Astronomical Union in record time, 3I Atlas. The 3I signifying it as only the third confirmed interstellar object in history, and Atlas being the unofficial name the original IRAS discovery team had allegedly given it a tribute to the Titan holding up the sky. But as the initial shockwave of confirmation subsided, a deeper, more analytical phase began. The true scientific treasure of the 1983 data was its duration. Unlike Oumuamua, which we saw for only a few weeks as it tumbled away from us, or Borisov, which was tracked for several months, IRAS had captured 3I Atlas over its full encounter. The satellite had mapped its approach, its closest pass to the Sun, and the beginning of its long departure. We didn't just have a snapshot, we had a feature film, and what it revealed was staggering. The first surprise was its thermal signature. Oumuamua was cold, reflecting sunlight but emitting very little heat of its own. Borisov glowed with the familiar infrared halo of a sublimating icy comet. 3I Atlas was different. The IRAS data sensitive to heat showed a faint but persistent thermal excess, a warmth that couldn't be explained by solar radiation alone. It suggested a slight intrinsic heat source, something geologically active or powered by a mechanism we had never before witnessed in such an object. Was it tidal heating from a close past to its parent star, or the decay of radioactive elements trapped within its core? The data posed more questions than it answered. Then there was the trajectory. Like Oumuamua, its path showed a slight non-gravitational acceleration, a tiny push away from the Sun that gravity alone could not explain. With Oumuamua, scientists had struggled to find a cause, with some speculating it was outgassing from unseen jets of vapor. But the IRAS data for 3I Atlas was far more precise. The acceleration was not a gentle, continuous push. It occurred in discrete, subtle bursts, perfectly correlated with the object's rotation. It was as if something was being vented, but only from a specific point on its surface, acting like a tiny, intermittent thruster with each turn. The object was not just passively tumbling through our solar system, it was actively interacting with it in a controlled, periodic way. This was behavior without precedent, a dynamic and complex interaction that blurred the line between a natural comet and something far more complex. The sheer size estimate derived from its infrared brightness also set it apart. While Oumuamua was thought to be a few hundred meters long, and Borisov, a few kilometers across, the calculations for 3I Atlas pointed to an object an order of magnitude larger. It was a behemoth, potentially tens of kilometers in diameter, a true leviathan from the interstellar deep. An object that large, with such a peculiar heat signature and controlled non-gravitational acceleration, was not just another data point. It was a paradigm-shattering anomaly, a celestial creature unlike anything in our biological or geological zoo. It was a visitor that should have rewritten our textbooks on planetary science, on the formation of solar systems, and on the very nature of what could wander the void between stars. It should have been the discovery of the 20th century. And as this new, breathtakingly detailed portrait of 3I Atlas came into focus, the initial elation within the scientific community began to curdle. The joy of discovery gave way to a chilling, deeply unsettling realization. The data was not ambiguous. It was not a borderline case that could have been misinterpreted. The evidence for its interstellar origin, its anomalous behavior, and its profound significance was as clear in the 1983 data as it was to the astronomers analyzing it today. There was no scientific rationale for its suppression. The original IRAS team would have seen the same impossible velocity. They would have calculated the same unbound orbit. They would have been stunned by the same thermal anomalies. They would have known without a shadow of a doubt that they had found definitive proof of a visitor from another star system. The debate in online forums and academic symposia shifted almost overnight. It was no longer about the object's perihelion or its spectral class. The conversation turned from astrophysics to human psychology to politics to fear. The undeniable proof of 3I, Atlas, was now laid bare for all to see, a pristine fossil excavated from a tomb of secrecy. And with it came the terrifying, unavoidable question that eclipsed even the discovery itself. We were not the first to see this. We were not the first to know. The evidence wasn't lost. It was hidden. The story wasn't forgotten. It was buried. The feeling of triumph began to evaporate, replaced by a cold, heavy sense of disbelief. You hold in your hands the proof, the absolute proof of an emissary from another star. You know it will change the world, reshape our understanding of the universe, and redefine humanity's place within it. What force, what fear, what command could possibly compel you to take that discovery and erase it from history? And so the ghost is finally exorcised from the machine. For decades, it haunted the margins of astronomical history, a phantom signal on a forgotten magnetic tape, a whisper of a truth we were not yet ready to hear. The journey of 3I, Atlas, did not begin when our modern telescopes first caught its faint, sunward glint. It began in the cold, silent vacuum of 1983, captured in a stream of infrared data by a satellite built to map the cosmos, but which inadvertently sketched the first known portrait of a traveler from another star. The revelation is not merely a correction in a textbook, a footnote added to the annals of astronomy. It is a fundamental reframing of our own story, a profound and unsettling realization that the universe has been knocking on our door for far longer than we ever permitted ourselves to believe. The silence that followed that first detection was not the silence of an empty cosmos. It was a human silence, a deliberate turning away, a choice made in corridors of power and quiet laboratories that has echoed down through the years, costing us something immeasurable: time. Think of the generations of scientists, of dreamers who lived and worked in the intervening years. Imagine the brilliant minds of the 1992 and early 2000s who theorized about interstellar wanderers, who ran simulations and argued in academic halls about their likelihood, their composition, their very existence. They were explorers charting a map, unaware that the first evidence of the new world they sought was already locked away in an archive filed under a different name, its significance unrecognized or perhaps deliberately obscured. Every calculation made in ignorance of this fact, every research grant denied for being too speculative, every young astronomer who abandoned the search for lack of evidence now feels like a missed opportunity, a tragedy of lost potential. We could have had a 40-year head start. 40 years to study its trajectory, to plan for its return, to develop the very technologies that would have allowed us to scrutinize it in breathtaking detail. 40 years to prepare ourselves scientifically and philosophically for the reality that our solar system is not a secluded sanctuary, but a crossroads on a galactic scale. The knowledge was there, a single dormant seed of understanding, that had it been allowed to sprout, might have grown into a completely different tree of cosmic knowledge. This belated discovery forces us to confront the true nature of our celestial neighborhood. We have long pictured ourselves as inhabitants of a quiet cul-de-sac, a stable, predictable system governed by familiar gravitational laws. The planets move in their stately procession, the comets arrive from the Oort cloud on schedule, and everything beyond was a distant, unreachable backdrop. 3I, Atlas, and the truth of its early detection shatters that comforting illusion. It reveals that we do not live in a cul-de-sac. We live on the shore of a vast cosmic ocean, an ocean teeming with unseen currents and filled with drifters from distant, unknown archipelagos. These interstellar objects are not rare once-in-a-civilization marvels. They are the flotsam and jetsam of galactic history, perpetually washing up on our shores. They are fragments of other worlds, messengers from planetary systems that lived and died long before our sun ignited. Their silent passage through our system is not an invasion, but the natural state of a dynamic, interconnected galaxy. And for 40 years, we kept our eyes fixed on our own local pond, while the tides of this greater ocean lapped at our feet entirely unnoticed. How then do we now view the legacy of a mission like the infrared astronomical satellite IRAS was by every measure a spectacular triumph? It was a technological pioneer, a marvel of engineering that peeled back the veil of cosmic dust to show us a universe crackling with the heat of stellar nurseries and galactic cores. It gave us our first comprehensive glimpse of the infrared sky, charting hundreds of thousands of previously unknown objects. Yet now its legacy is forever twinned with this profound omission. It is both a monument to human ingenuity and a cautionary tale about human fallibility. It stands as a testament to our ability to build machines that can see across the cosmos, but also as a stark reminder that seeing is not the same as understanding. The data was perfect. The signal was unambiguous. The failure was not in the hardware orbiting high above the Earth, but in the software of our own perceptions, our own priorities, and our own fears. IRAS will be remembered for the wonders it revealed, but it will also be remembered for the one spectacular wonder it held back, a secret kept not by the satellite itself, but by the very civilization that created it. It becomes a symbol of a critical lesson, that the most significant barrier to discovery is often not the technological challenge of gathering data, but the psychological challenge of accepting what it tells us. This entire saga transforms from a simple story of astronomical discovery into a powerful, undeniable argument for a new era of scientific transparency. The culture of secrecy born from the tensions of a Cold War world has no place in our exploration of the cosmos. The universe is too vast, the data too complex for any single institution or nation to act as the sole gatekeeper of knowledge. We now understand that a discovery deferred is a discovery denied to the entire human family. The decision to classify, to shelve, to simply ignore a signal because it is anomalous or inconvenient is an act of generational theft, robbing future scientists of their rightful inheritance of information. It sparks a new and urgent calling, the rise of the data archaeologist. We must now turn back to our own archives, to the mountains of data stored on aging tapes and primitive hard drives from missions past. We must revisit them not with the eyes of 1983, but with the perspective and the advanced computational tools of today. What other ghosts lie dormant in those old machines? What other interstellar visitors? What other inexplicable phenomena? What other clues to the fundamental nature of the universe are waiting to be found, hidden not by cosmic dust, but by human neglect? The story of 3I, Atlas, is a call to action. A. Demand that all data gathered in the spirit of pure exploration be made open, accessible, and available to every curious mind on the planet. The next great discovery may not come from the pristine billion-dollar mirror of a new space telescope. It may come from a graduate student in a university library running a new algorithm on decades-old data, finally noticing the one faint signal that everyone else missed. This is the promise of open science, that 1,000 pairs of eyes are better than a few, that collaboration trumps competition, and that the collective intelligence of humanity is our single greatest tool for deciphering the cosmos. Secrecy builds walls, but transparency builds bridges. Bridges across disciplines, across nations, and most importantly, across time. It ensures that the discoveries of today are not lost to the scientists of tomorrow, creating an unbroken chain of inquiry that stretches back into the past and reaches forward into a future of shared understanding. The data from missions like IRAS does not belong to any government or agency. It is the property of the human species, a collective inheritance of cosmic light. This revelation also reshapes our very definition of discovery. We tend to imagine it as a singular moment of blinding insight, a eureka shouted in a lab, an apple falling on a theorist's head. But the truth is often far more complex, more gradual, and more deeply human. Discovery is not just the initial act of detection. It is a process, a slow and sometimes arduous journey of recognition, verification, and finally acceptance. The universe, it seems, does not always shout its secrets at us. Sometimes it whispers them, and it is our responsibility to learn how to listen. The signal from 3I, Atlas, in 1983, was one such whisper. It was a message that arrived before we had the language to comprehend it. A single, anomalous pixel in a vast celestial mosaic. Its journey from a mysterious data point to a recognized interstellar object is a story about how science truly works, not in clean linear steps, but in fits and starts, with long periods of confusion, punctuated by moments of sudden stunning clarity. It reminds us that our understanding of the universe is not a finished, polished monument, but a living, breathing entity, constantly being revised, corrected, and expanded by new evidence, and sometimes by old evidence seen in a new light. Knowing that we have been visited unknowingly for so long imbues our modern search with a renewed sense of urgency and purpose. The great sky surveys of our time instruments like the Vera C. Rubin Observatory are not just charting the unknown. They are, in a sense, making amends for the past. They are designed with the explicit philosophy of openness that was absent in a previous era. Their digital eyes will scan the entire visible sky every few nights, creating a motion picture of the cosmos in unprecedented detail, a film that will be shared with the world in near real time. They will not just look for faint points of light. They will be explicitly hunting for the travelers, for the outliers, for the objects moving on trajectories that defy a solar system origin. We are no longer just looking for neighbors within our picket fence. We are now scanning the horizon for ships arriving from distant shores, armed with the knowledge that they have always been coming. Our search strategy has fundamentally changed. We have shifted from a passive stance waiting for an object to dramatically announce itself to an active, persistent hunt, sifting through torrents of data for the subtle signs of their passage. We are no longer just stargazers. We have become cosmic watchmen on the walls of our own solar system. And so we are left here, under the same sky, but in a profoundly different universe. A universe that feels at once both larger and more intimate. Larger because the true scale of galactic traffic, the sheer number of worlds shedding fragments into the void, is beyond our previous imaginings. And more intimate because we are not alone in our cosmic solitude. We are part of a vast, interconnected web, a galactic ecosystem where the raw materials of one solar system can over eons drift into another. We are made of stardust, as the saying goes, but we now understand that some of that dust may have originated from stars we cannot even see, from suns that have long since faded from the sky. This knowledge carries with it a heavy weight, a dual sense of both wonder and caution. The wonder lies in the boundless possibilities. What other messages are encoded in these cosmic drifters? What secrets of planetary formation, of alien chemistry, of the very history of our galaxy, are locked within their icy hearts? They are time capsules from other worlds delivered directly to our doorstep, waiting for us to develop the means to read their contents. They offer the tantalizing prospect of studying extrasolar material firsthand, a dream that once belonged to the realm of science fiction. But there is also a profound sense of caution, a humility born from the recognition of our own past blindness. If we could miss something so significant for so long, what else are we missing right now in plain sight? What subtle signals are our instruments recording that we, trapped in our current paradigms, are failing to recognize? The story of continent 3I, Atlas, is the ultimate cosmic cautionary tale, a lesson written across the sky that our assumptions are the most powerful filters capable of rendering even the most obvious truths invisible. It compels us to look at the universe with new eyes, to question our certitudes, and to embrace the anomalous. We must learn to cherish the data points that don't fit the signals that defy easy explanation. For it is in these perplexing whispers that the next great revolutions in our understanding are likely to be found. We stand on the cusp of a new age of discovery, an age defined not just by what we seek, but by our willingness to see what is already there. The cosmos, we have learned, is far stranger, more dynamic, and more wonderfully interconnected than we ever dared to imagine. And our journey into it has, in a very real sense, only just begun. The sky above is not just a ceiling of distant lights. It is a thoroughfare, and we have finally, after a long and costly delay, begun to read the traffic signs. The only question that remains is where these ancient roads will lead us next.